Step into the next era of computing with quantum technology. Few technologies have been as revolutionary or exciting as quantum mechanics. Just a mention of the term is like pulling a page from a sci-fi franchise and putting some incredibly advanced technology inside our own data centers. Quantum technology promises to revolutionize computing, and its capabilities are already being felt in research and scientific endeavors. But where does the term quantum come from? And what does it really mean? Here we'll go over the basics of quantum computing and why it causes such a buzz in the computing world. To dig deeper on quantum computing and other emerging technologies and trends, visit our dedicated site at the link above or in the description below. And remember to subscribe to Ion Tech for more videos on all things business tech. The term quantum originates from the Latin word quantus, meaning how much, or amount. But the term really took hold in modern physics, where quantum refers to the smallest distinct units of matter or energy. These include photons of light or other subatomic particles, such as electrons. Quantum physics, the study of these various quantum atomic and subatomic particles, focuses on the unique relationships and behaviors that these particles exhibit. Quantum particles show several important behaviors, including superposition, which allows a quantum particle to exist in many possible states simultaneously. Uncertainty, which states that it's impossible to know the state of a particle with perfect accuracy all the time. Coherence, which is continued predictable state of the particle. Decoherence, which is the loss of coherence and superposition. Entanglement, which is the relationship and interaction of particles over a distance. And wave-particle duality, which describes how particles can behave like both waves and particles. Researchers and engineers can harness quantum particles for practical applications like processing quantum information, performing quantum calculations, and facilitating quantum communication, all because of a quantum particle's spin. In traditional computing, a bit is either a 0 or a 1. But a quantum particle's superposition characteristics actually allow the particle to represent any state between the two, with a degree of uncertainty. A quantum bit is called a qubit and can exist in a superposition of both 0 and 1 simultaneously. This allows qubits to represent and process more complex information at the particle level, enabling quantum computers to perform certain calculations much faster than classical computers. It's this speed which makes quantum computers so appealing for computing and scientific work. The profession dedicated to designing and building practical applications for quantum particle behaviors is called quantum engineering. Experts anticipate that quantum computing will bring notable changes to technology, cybersecurity, healthcare, and many other fields. But there are still significant challenges to overcome before these technologies become mainstream. Do you think the future is quantum? Why or why not? Share your thoughts in the comments and remember to like and subscribe too.